The basic process of generating code, tuning parameters, and logging data is shown in the Introduction to Simulink Coder video. This video shows how to extend those capabilities using Embedded Coder and add-on to Simulink Coder. Let's generate C code from this simple aircraft model by pressing the Build button and observe the code generation report which pops up at the end of the build process. The static code metrics report shows the global RAM usage, lines of code, and other metrics. The RAM usage is around 116 bytes, which seems large for this simple model. But notice in the core itself, there is quite a bit of overhead due to mat file data logging and error management code. This is useful for rapid prototyping or hardware-in-the-loop applications commonly used with Simulink Coder as shown in the earlier video, but not for production code generation using Embedded Coder. Now let's use the Code Generation Advisor to identify coder settings that will improve RAM efficiency. Notice the suggestion to disable mat file logging. Let me go ahead and change all parameter modifications suggested at once. Now let's regenerate the code and look at code metrics report. As you can see, there is a visible reduction in RAM usage along with fewer files and lines of code. So by changing a few parameters as suggested by the Code Generation Advisor, we can get more efficient code without changing the model and simply leveraging optimizations in Embedded Coder. You can also customize the appearance of the generated code using Embedded Coder. For example, if you'd like to customize the names of the initialize and step functions, perhaps to aid software integration, you can do so just by changing a few configuration parameter settings. I can change the function names to roll_init and roll_step here. Now let's validate this. Generate code again and observe the new function call interface. You can also configure how model data is represented in generated code using data objects and custom storage classes. For example, I will configure these two signals such that the code generator treats them as exported globals in the generated code. Notice here that the storage class is set appropriately. The generated code will now have these signals defined as exported globals as shown here. You can control parameters also the same way as signals. Embedded Coder offers many customizations and optimizations beyond those shown here. For example, code replacements offer built-in support for popular devices like ARM Cortex cores that you can download from our website. With code replacements, instead of ANSI ISOC for DSP filters and math operations, you can generate highly optimized code for orders of magnitude faster execution on SIMD, Intel IPP, or Neon-supported processors. Code replacement offers a published API in case you want to replace functions unique to your processor. For more information, including a step-by-step tutorial on Embedded Coder and its capabilities, click on the links below.